Okay, welcome back, Stella. Last time we basically saw how to integrate this whenever the discriminant is greater than 0, when the discriminant is equals to 0, and when it is less than 0. So, in this video, we're basically going to see some exercises. I'll solve some and you have to solve the rest. Okay, these are the exercises that we are going to do. So, these are the exercises on type 3, F, G, and H. These are the exercises that concern that type. These are extra exercises. I just added them for me. My aim here is to basically see if you've really mastered all what you have been doing from the beginning of this integration of rational functions. Yes. So where you see a star, these are the exercises I'll do. So I'll do this first one, I'll do this second one, I'll do this fifth one, and on the extra exercises, I'll do this 6 and 7, and this number 6 and number 5. I'll just give you hints on how you proceed to do the other ones. So without wasting time, let's dive directly into the exercises. So the first one exercise we have to do is the integral of 5 all over x squared plus x minus 6. Okay, let's dive into our paper. Exercises. We are on the page 38. Exercises on type 3, F, G, and H. Okay, so we are to do the first question. The first number one was the integral of 5 all over x squared, I think, plus x minus 6 dx. Let me verify. Yes, that's it. Okay, as I said, whenever you are in such a situation, in such an integral that is something like this, you have to integrate. The first thing you have to do is, first of all, we notice that this is of the form a on ax squared plus bx plus c, where our a belongs to r star. Okay, the first step we have to do is to calculate delta. We know that delta is equals to b squared, that is the discriminant, b squared minus 4ac. In this equation, our a is equals to what? 1, our b is equals to 1, and our c is equals to minus 6. So this will be equals to b squared minus 1 squared minus 4 into a, our a is 1, times c minus 6. This will be equals to what? 1, this 4 times this is 24, and minus this will become plus 24. So this implies our delta is equals to what? 25, which is greater than 0. Since our delta is greater than 0, it implies what? X squared plus x minus 6 has two real and distinct roots. Two real and distinct roots. Okay, let's now find these roots. We know that x will be equals to minus b plus or minus the square root of delta all over 2a. So this will be equals to minus b, this is our b, minus 1 plus or minus the square root of delta is 25 all over 2 times 1 is 2. So basically our x1 will be equals to, that is, x will be equals to minus 1 minus the square root of 25 is 5 all over 2, or x will be equals to what? Minus 1 plus 5 all over 2. So let me go to the next page. This implies x will be equals to where is it? This is minus 6. Minus 6 divided by 2 is minus 3. This gives 4. 4 divided by 2 is 2. So we basically have x equals to minus 3, or x equals to what? 2. So this implies x squared plus x minus 6 must be equals to what? X into x plus 3, because this 3 comes like this. X plus 3 into what? X minus 2. That's it. So that's it. We have already written our quadratic expression as a product of what? Two factors. If you develop this, you notice that it gives this. So it implies the integral the integral of 5 on, okay, of 5 on what? On the x squared plus x minus 6 dx will be equals to what? 5 into what? 1 all over integral of 1 all over what? X plus 3 into what? X minus 2 dx. We now have to integrate this. So at this stage, we cannot integrate this directly. What we are supposed to do here is what? We express this in what? Partial fraction. So step 2, let's first express 1 on the x plus 3 into x minus 2 in partial fractions. In partial fractions. In partial fractions. Okay, let's express that in partial fractions. We basically know that 1 all over x plus 3 into x minus 2. How are these factors under here? These are linear factors. So this impartial fraction will be identical to what? This will simply be, so these are linear factors. So this impartial fraction will be identical to what? A on x, this is a linear factor, x plus 3, plus b on what? X minus 2. Okay, so this one on x plus 3 into x minus 2 will be identical to what? Find the LCM here. The LCM is x plus 3 into x minus 2. So this divided by this will give a into x minus 2, a into x minus 2, plus b into what? X. This divided by this gives b into x plus 3. So you see that this fraction is identical to this fraction, but the numerators here are identical. So for these two fractions to be equal, necessarily the numerator has to be identical to this other numerator. So this implies one must be identical to what? A into x minus 2 plus b into what? X plus 3. Okay, there is a very, as I told you in previous videos, you can decide to develop all this. You come out with a system, you develop all this, and you equate like terms to what is on the left, and you will come out with a system of equation that you will resolve and find a and b. But look at something. Whenever I have things like this, factors like this, it's very simple to find. For me, I see that there is no need, there's really no need of developing this, because by just letting, look at something. If I let, when I solve this equals to 0, I have x equals to 2, and when I solve this equals to 0, I have x equals to minus 3. So if I take the first condition, when x is equals to, when x, if I want to find b, the best way to find B will be to eliminate what? A. So to eliminate A is, I need to make what? This become equals to 0. So I can take the first condition will be when x equals to, let's say 2. Yes, 2. This will become 0. I will substitute the 2 here and I will deduce the answer for B. The next other one is I will make B to become 0. So when x will be equals to minus 3, this will become 0 and I will be capable of deducing what? A. That's a very this is a very simple thing to resolve. So there is no need to develop this and find in order to find A and B. So the first condition, when I will take when x is equals to 2. When x is equals to 2, I'll come and substitute it here. I'll have 1, which will be equals to what? A. When I put 2 here, I have 0 plus B into what? 2 plus 3. So this implies, so this implies, so this basically implies 1 will be equals to what? 5B, implying B will be equals to what? 1 on 5. You have already your B. So let's proceed to calculating A. To calculate, to have A, I need to eliminate B when x is equals to what? Minus 3. When x is equals to minus 3, I'll have 1 being equals to what? A into minus 3 minus 2 plus B into what? 0. So so this implies uh, 1 will be equals to what? Minus 5A, implying A will be equals to what? Minus 1 on 5. So this is your A. Now we have already A and B. So it simply implies 1 all over, because this is the partial fraction we're finding. Let me go up. This is the partial, this is what we wanted to express in partial fraction. This is what we wanted to express in partial fraction. So this will be equals to, the A was under x plus 3. So 1 on x plus 3 into x minus 2 will be equals to what? Minus 1 on 5 all over x plus 3 plus what? Plus B was 1 on 5. 1 on 5 all over what? All over x minus 2. So it implies 1 on the x plus 3 into x minus 2 must be equals to what? Must be equals to I'll bring this in front. This will become 1 on 5 into x minus 2 minus, because there is a minus here, 1 all over 5 into x plus 3. So we have already expressed this in partial fraction. So don't forget that this is where we ended. This is where we ended. Don't forget this 5 outside. So be very careful. So the integral of 5 all over x squared plus x minus 6 dx will be equals to, which was equals to 5 into the integral of 1 all over x plus 3 into x minus 2 dx. This will be equals to what? This will be equals to, we express, I will just substitute this by this because this is the partial fraction we just had. So this will be 5 into what? The integral into the integral of all this, that is 1 on 5 into x plus 3 minus 1 on 5 into x minus 2, all of this dx. So this will be equals to 5. You are not authorized, don't always put the equals to sign here, it's just that I want to fill this space. 2 equals to sign must not be found on the same spot. So I will have 5 into what? 5 into 1 on 5 integral of what? Integral of 1 all over x plus 3 dx minus 1 on 5 integral of what? 1 all over x minus 2 dx. So you close the big brackets. You see that this 5 will cancel this 5 and it will also cancel this 5. Okay, let's go to the next page. Let's go to the next page. So we will be left with the integral of 1 over x plus 3 dx minus the integral of 1 all over x minus 2 dx. So this will be equals to the integral of 1 all over x plus 3 dx minus the integral of 1 all over x minus 2 dx. Okay, now basically we know how to integrate this, because this is the integral of 1 all over ax plus b dx. So the integral of this will simply be equals to what? 1 all over what? X plus 3 prime ln of the absolute value of x plus 3. Now minus the integral minus, okay, minus 1 times the integral of this. The integral of this will be 1 all over what? X minus 2 prime ln of what? The absolute value of x minus 2 plus our constant of integration k belonging to r. Okay, when I differentiate what is under here, it gives me 1. When I also differentiate this, it gives me 1. So this will be equals to simply ln of what? The absolute value of x plus 3 minus the differential, the derivative of this is 1. So ln of the absolute value of what? X minus 2 plus our constant of integration k. Notice that the ln of a minus the ln of b is equals to what? Ln of a is equals to ln of a all over b. I know you should remember these rules of logarithm. The ln of a minus the ln of b is equals to the ln of a on b. So I will rearrange this. This will permit me to rearrange this. So it implies the integral of 5 all over x squared plus x minus 6 dx will be equals to ln of the absolute value of x plus 3 all over what? X minus 2 plus our constant of integration. So that's the integral of this function. So that's your answer. So that's basically your answer. So that was all for this exercise. Let's move to the next exercise, which is what? This integral. So the integral of what? You will do this, the integral of 1 all over x squared minus 4x plus 4. Okay, let me go to this. So we have, that's question 3, integral of 1 all over x squared minus 4x plus 4 dx. Let me verify. Okay, that's it. Now we still notice that it's still in the form a on ax squared plus bx plus c. Understand, where a belongs to r star. Okay, naturally the first step to do is to calculate what? The discriminant. So I'll calculate delta, which is equals to b squared minus 4ac. Our a here is 1, our b is equals to minus 4, and our c is equals to 4. Now this our delta will be equals to b squared, so minus 4 squared minus 4 squared minus 4 into a is 1, and c is what? 4. This will be equals to 16 minus 16, so implying delta is equals to 0. So we see that the discriminant is equals to 0. It implies what? It simply implies that this quadratic expression has real and repeated roots. So it implies x squared minus 4x plus 4 has real and repeated roots. So let's find those roots. X will be equals to what? X will be equals to minus b plus or minus the square root of delta all over 2a. But our delta is already 0, so this will become equals to minus b all over 2a, because if delta is 0, this becomes 0 and we are left only with what? Minus b on 2a. So that repeated root x will be equals to what? Minus b. What was our b? Our b is minus 4. So we have minus 4 all over 2a. A is 1. So this implies our x will be equals to what? Our x will be equals to, this is 4 divided by 2, 2. So it implies x squared minus 4x plus 4 must be equals to what? When this comes like this, it becomes x minus 2. So this will be x minus 2 all that square. That's the repeated factor. Now, it then implies the integral of 1 all over x squared minus 4x plus 4 dx will be equals to what? Integral of 1 all over what? X minus 2 all that square dx. And we basically know how to integrate this. This is a linear expression. So we are basically in the form. We are basically trying to integrate what? 1 all over ax plus b to the n dx, and we know how to integrate this. So this will be equals to the integral of what? X minus 2 to the minus 2 dx. So when we integrate this, this is simply equals to 1 all over what? X minus 2 prime times what? X minus 2 to the minus 2 plus 1 all over minus 2 plus 1 plus our constant of integration. So this implies the integral of 1 all over x squared minus 4x plus 4 dx will be equals to what? When I differentiate this, it gives me 1. This plus this gives minus 1. So I'll also have minus 1 here. So this will be equals to minus 1 all over what? X minus 2 plus our constant integration. So that's the integral we just had. Let me create a new sheet of paper. 4344. Okay. So that's how you integrated this. You see that it's very simple. So let's move to the next one. We're going to integrate this. So it's 15 on 4x squared plus 8x plus 13. Let's move to the next paper. That's question 5. Integral of 15 all over 4x squared plus 8x 15 all over 4x squared plus 8x plus 13. Okay, plus 13 dx. Okay, the first thing, we basically see that this is in the form a on ax squared plus bx plus c, where a belongs to r star. Our a here is naturally 15. So what we naturally have to do here is we first need to calculate delta. Step 1, delta, which is equals to b squared minus 4ac. Our a here is equals to what? 4. Our b is equals to 8, and our c is, wait a minute, and our c is equals to what? 13. Let me divide it into 2 for me to really well exploit this space. So let me go down with the line. Let me go down. Okay, okay, let's move up. So our delta will be equals to what? Our delta. So our wait. So our delta will be equals to what? B is 8, so we're going to have 8 square minus 4 into A, which is 4 times what? 13. Yes, C. This, the 8 is equals to what? 8 is equals to 64 minus 4 times 4 is 16, and 16 times 13, let me 16 times 13, this gives 208. 208. You basically see that, okay, let me do the difference. Minus 64 minus 64. So you basically see that delta is equals to what? Minus 144, which is less than 0. So we basically see that the discriminant is less than 0. This implies 4x squared plus 8x plus 13 uh, 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 does not has real roots. Real roots, or has what? Imaginary roots. Imaginary roots. Okay. Now, what was said, whenever we notice that the discriminant is less than 0, what are we supposed to do? We are supposed to write back this. We are supposed to complete the square of this. So our next step, let's complete. Let's write. Let's write 4x squared plus 8x plus 13 in completed square form. In completed square form. I told you in previous video that I really encourage you to use the completed square formula for you to be fast in your way of solving. So recall that I'll just recall that ax squared plus bx plus c in completed square form is equals to what? A into is equals to a into x plus b on 2a square minus delta all over 4a square. Let me check. I hope I did exactly. So so we have already our formula. So this implies we know that our A is our A is 4, our B is 8, and our C is equals to 13. And we've calculated already the discriminant delta. We saw that delta was equals to what? Minus 144. Okay, very good. So this implies 4x squared plus 8x plus 13 will be equals to what? Will be equals to, our A is 4. 4 into what? 4 into, I'll have x plus what? Our B is 8. 8 all over what? 2a. 2 times, let me substitute, 2 times 4. All that square. Minus, our discriminant is what? Minus 144. Minus 144. All over what? 4a squared. 4 times a squared. This is 4 squared. Okay. I'll close all of this. So this will be equals to 4 into, this is 8. This is 8 divided by this is 8, yes, divided by what? 8. So I will have here x plus 1 squared minus, this is okay, with this minus this becomes plus. So we're going to have 144. 16, 16 4 square is 16, and 16 times 4 is 64. Okay, so I have 64. This will give 144 on the 64. Okay, this is what we'll have. Now, I'll multiply all through. I'll multiply all through by this 4. I'll multiply all through by this 4. This becomes 4 into x plus 1 square plus what? 144 on the 6. 4 here, 1 times 4 here, it gives 16. Okay. Okay, I think let's try to simplify 144 on the 16. 2 here 8 times, 2 here 7 times, 2 here 2, yes, 2 here 7 times, 2 here 2 times. Okay, let me try to see. 72 divided by 8, it gives 9 times. So you could just even divide 144 by 16. 144 by 16 is 9. So it implies 4x squared plus 8x plus 13 in completed square form will be equals to 9, because this gives 9. 9 plus what? 4 into x plus 1 square. Very good. Okay, now let's continue with the integral. So it basically implies that, so we have already completed the square of this. We've completed the square. This is it. That's the completed square form. So we want to integrate this. So it basically implies that the integral of 15 all over 4x squared plus 8x plus 13 will be equals to what? 15 into, I'll substitute this by this, 1 all over what? 9 plus 4 into x plus 1 square. Very good. Dx. Okay, now we have to integrate this. We have to integrate this. Okay, how do we integrate this? When you look at this, remember, I want you to recall something very important. We saw how to integrate 1 all over a plus bx squared dx. I taught you how to integrate this. Now, are you not seeing that this is basically in this form? Is basically in this form, with the only difference that this x has been replaced by what? X plus 1. So this x plus 1 is behaving like a big X. You understand? So look at what I will do. Look at what I will do. I will do this in 2 different ways. I'll do this in 2 different ways. Okay. The first way, this is what I will do. So this our form, we know a plus bx squared. A plus bx squared dx. So we said that whenever we are in such a situation, to integrate this, we basically know that the substitution here will be what? Tan theta being equals to what will be all square. Okay, that's very good. If you can remind that, that's already very good. So whenever we have to integrate this, what do we have to do? The first thing is to, this is the basic form we know, 1 plus x squared. The first thing to do is to make this one, this where there is a here, to become what? 1. After doing that, we will bring all what is inside here inside what is inside the square before doing our substitution. So I'll apply it here. So this will be equals to 15 into the integral of what? I will factorize this a, this 9. So 1 all over what? 9 into, when I factorize 9 here, what remains here? 1 plus what? Since there was no 9 here, this becomes 4 on 9 into what? X plus 1 squared. Very good. Okay. Now, what is the next step? We have already 1 here. We have already a 1 here. The next step is to do what? Is to bring all what stays outside here inside the square. So we have to do everything possible for this 4 on 9 to go inside here. And I told you our technique is what? We take the square root of this all square. So this integral, so this will be equals to what? This will be equals to 15 into wait a minute, let me first write this, let me first bring this 9 on this other side, you understand? So this will become, this will be equals to 15 on 9 integral of what? 1 all over, let me check it, 1 1 all over 1 plus 4 on 9 into x plus 1 all that square. Done. This will be equals to 1 all over 4 on 9 into x plus 1 all that square dx. Okay, all that square dx. Okay, now at this stage we are to bring all of this inside this square before doing our substitution, you understand? So I'll write this back as 15. Okay, I can simplify some. There is 3 is common here, so 3 here 5 times and 3 here 3 times. So this will simplify to 5 on 3 integral of what? 1 all over what? 1 plus, I write this as the square root of 4 all over 9 all that square into what? X plus 1 square dx. Very good. Now, since these two are already having squares, I'll bring, that permits me to bring what? This guy inside. This will be equals to 5 all over 3 integral of what? 1 all over 1 plus what? I will have 1 plus, I'll open big brackets. This will become x plus 1 times what? The square root of what? 4 on 9. All of this square dx. Very good. It's already inside. But let me simplify this because the square root of 4 on 9, this will simply the square root of 4 over the square root of 9, which gives 2 on 3. So this will be equals to 5 on 3 integral of 1 of dx all over 1 plus what? 1 plus, I open these big brackets, 2 all over 3 into what? X plus 1 all that square. So you basically see that this integral is already resembling what? 1 plus, it's already resembling 1 plus what? Something all that square dx. And we know that when we are in a situation where we are integrating 1 all over 1 plus something else, something which is inside all square, the best substitution is what? Tan theta must be equals to what? What is inside the square. So this is what is inside the square here. So the substitution we are going to do here, so we are going to let tan theta to be equals to what? 2 on 3 x plus 1. That's the substitution. So we let tan theta to be all of this. We know already that we are going to substitute all of this by what? Tan theta. But what will be the x? To have the x, we simply differentiate what? This implicitly. When I differentiate this, the derivative of tan theta is what? sec square theta or 1 plus tan square theta. So I'll have 1 plus tan square theta. Since I am differentiating implicitly, I write here d theta, which must be equals to, when I differentiate this, don't be afraid, this is simply equals to 2 on 3x plus 2 on 3. When I differentiate this, the derivative of this one behind here will give 0, so times dx, that's 0. So when I differentiate this one, I'll simply have 2 on 3. And since I was differentiating with respect to x, I write what? Dx. Very good. So let's proceed. Let me wipe this. Okay, now we are to make dx the subject because we shall substitute it here. You understand? So from here, my dx will be equals to what? 1 plus tan square theta times d theta all over what? All over 2 on 3. That's it. Implying dx will be equals to what? Since there is a 1 here, divided by this becomes 3. Oh God. This becomes 3 on 2, 3 on 2 into what? 1 plus tan square theta d theta. Okay, everything is already okay. Now we have already our substitution and we have dx. Let's then replace it inside this integral. So let me wipe what is under here. Let me wipe this. So this implies, sorry, the video is a bit long, but it's very important for you to understand what is going on. So 5 on 3 integral of dx all over 1 plus 2 on 3 into x plus 1, all that square, will be equals to what? Will be equals to, I'll have my 5 on 3 integral of what? What was my dx? My dx, I replace my dx. My dx is 3. Oh, sorry. There was an error. Okay, let's continue. So I replace my dx by what? 3 on the 2 times 1 plus tan square theta times d theta all over what? All over what was our substitution? So we should replace this by what? Tan theta. And notice that, so I will have 1 plus, since there is a square here, this becomes tan square theta. Okay, you notice that this will go with this. Is that okay? So this will be equals to what? 5 on 3. This comes out times 3 on 2 integral of what? What remains here is simply d theta. So this will be equals to what? This 3 goes and we'll have 5 on 2. The integral of d theta is what? Theta plus our constant of integration. But I told you, whenever you are integrating, if the starting variable was x, always give your answer in terms of what? The starting variable. Now, how do we find theta? We can recall that from our substitution, tan theta was equals to what? This. So recall that tan theta was equals to what? Tan theta was equals to 2 on 3 into what? X plus 1. From this, we can deduce that theta will be equals to what? Arc tan, or the tan inverse of what? 2 on 3 into x plus 1. So this implies, so it then implies the integral we were looking for. So this 15 on the 4x squared plus 8x plus 13 dx will be equals to what? I just substitute this theta where I see this. Let me precise here, k belonging to r. So I'll just replace this theta here. This will give me 5 on the 2 arc tan of what? Arc tan of 2 on 3 into x plus 1 plus what? plus our constant of integration. So that's how you integrate it. Is that okay? You see that it's very simple. So as I said, the first thing we notice that it was in this form. We calculate delta. We notice that our delta was less than 0. This means that the quadratic expression has imaginary roots. The next step was to write this quadratic expression in a completed square form. So this is the completed square formula. I recalled using this formula that permitted me to easily write this expression in a completed square form. So this is the completed square form we have. After obtaining the completed square form, we have the integral of this will be equals to 15 into the integral of what? I replaced this by the completed square form. Now, after replacing it by the completed square form, I noticed that this was identical to what? It resembles what? A plus b. It is as if I was integrating a plus bx squared dx. And we know that whenever we have this form, the only difference here is that here we're having x plus 1, but it's not a problem. And here we're having x, but they are basically identical forms. So, and we know that the basic substitution here will always be what? Tan theta being equals to what? What will be all squared. So how are we going to proceed here? The first thing is to make this a to become what? 1 plus all what will remain here, will bring it inside, and we will have something all squared. After writing this in this form, it will be very easy and we'll be in the best situation to use our substitution tan theta being equals to what is inside square. So what I did here, the first thing was to bring a 1 here. So I factorize what? 9. This becomes 1 plus, since there is no 9 here, I have 4 on 9. I write it back. This is what we have. I simplify this, and the next step is what? Is to bring all what is outside here inside what is square. So the best technique I showed you is to write what is outside square root of that all square. Now after writing that, the two are already having the same power, so that permits us to bring this inside and to elevate all of that square. That's what I did. And I simplified this. I know that this becomes this is the same as the square root of 4 over the square root of 9. So this gives me 2 on 3 into this all square. Now since everything is already in this form, as since we are already in the form 1 on 1 plus something squared dx integral, the ideal substitution is to let tan theta to be equals to what is inside the square. You understand? After letting it, we basically find what? Dx. To obtain dx, we have to differentiate this implicitly. Now this is what I did, and I had dx. I then take dx and this tan theta, I substitute in our integral. So we are going to have 5 on 3 integral of dx all over 1 plus this being equals to 5 on 3. I substitute everything. I see that this and this goes, and we are left with this integral, which gives us 5 plus 2 on times theta plus a constant of integration. But we recalled that tan theta was equals to what? Our substitution was tan theta being equals to this. This means theta equals to what? The arctan or the tan inverse of this. From there, we conclude that the integral of this is equals to 5 on 2. Where I see theta, I replace this arctan of this plus a constant of integration. So that's basically how we basically saw from these 3 examples. We basically went through how to integrate what? We basically went to how to integrate this when the discriminant is greater than 0. That was the first case. We saw how to integrate this when the discriminant is equals to 0. That was the second case. And we ended up by seeing how to integrate this when the discriminant is less than 0. This video is already very long. It's already more than 50 minutes. So let's catch up in the next video where we're going to basically see these two other examples, and I'll give you hints for the next. Try to do this one and this last one we did not do. In the next video I'm going to solve this and this, and I'll give you hints on, try also to do this already. I'll also give you hints on how to do this. So see you in the next video, and try to go through this video and try to master the approach that's behind, in fact the technique that's behind solving such integrals. See you in the next video.